Hey everyone. Yeah, on the note of questions, probably because this is being recorded, maybe save them till the end. Normally I'd say just interrupt me so you don't lose your train of thought, but if you save them till the end so the recording's coherent, I guess. So yeah, I'm Joe Kirwin. This is a talk about some of the shortcomings that I've perceived from two-factor authentication, both push and time-based one-time pad, HMAC-based one-time pad, and a proposal for some designs that I think could mitigate some of those issues. I know you. Do I know you? I feel like I know you. Okay. So anyway, if you don't take anything else away, I guess the problem with 2FA that I've found is that it's got abused from its original design. So when the RFC was first put out in 2005 for HMAC-based one-time pad, the design was supposed to be for mitigating consumption of breach data. But since then, it's been proposed to be something that would protect you from phishing and something that would protect you from confirming something out of band. So each of those, the second one is in reference to push-based 2FA. The first one applies to push-based and also TOTP two-factor. So just to bring everyone to the same level, I know probably most of you already know how the OTP scheme works, most likely better than I do. But if we go for the first one, which both of these are counter-based one-time pads, TOTP and HOTP both use this HMAC design. And the reason they use that, one is for integrity of the code, but also because HMAC is collision resistant under truncation, they can truncate something very long to a 6-character string and still have the integrity guarantees of the HMAC. So most of them, what they do is they change this HMAC counter in here. This is the thing that varies amongst all the different schemes. But the majority of the schemes are just HOTP or TOTP, which is this other one. And the way this one works, it just takes the time from epoch until now, subtracts that from when the token was created, divides that by a period, which might be like 30 seconds, minute, whatever, and then it just floors that to give you an integer value. And then essentially that just becomes the same as the normal counter-based one-time pad. And that's all it's doing when it's sharing the QR code with you. When you take the QR code and that goes into your Google Authenticator, all that's doing is transferring the secret and the time seed. So yeah, what's the problem with this? So if I was to talk through something homoglyph type attack, here we have live.com. So this would be like the Microsoft domain. And if we look at another domain that I could purchase, that would be iive.com. And if I capitalize the I, it looks indistinguishable from live.com. I can also get a TLS certificate for free from Let's Encrypt. And then simply just forward across these details, and I'll show a demo of how we could go about that in a second. Did we encounter this type of issue before? And the answer is yes, we did. In around 2005, when they released HMAC-based one-time pad, there was also a scheme called CRAM MD5 that some of you may be painfully aware of that we don't use anymore, right? Anyway, so they found this to be an issue. They cited it, and they cited this attack at the same time that the RFC came out for HMAC-based one-time pad. But interestingly enough, these two parties never discussed those things together. So I'll just move to a demo, and I'll just check that this is all right for everyone. Everyone see that okay from the back and such? So what we've got here is anyone familiar with Heroku? Anyone hands used Heroku? So I took a domain called Heroku.com, just spelled with an I instead of an E. And essentially, if I just jog the video back, it's really easy to create these types of things. All you do is just save that page, and then you just do a bit of GIMP if you're cheap like me, or you use Photoshop if you're a rich man, and then you just change the characters to make it look indistinguishable from an actual Heroku thing. I didn't actually purchase this domain because I thought that would be somewhat kind of criminal. So I instead just put an SE hosts entry for this. So excuse me if this is not a legit SSL certificate, but this domain was available, so I could have bought it. I just didn't want to kind of blur the lines between white hat and black hat for this one. And then the other thing we've got is just an Android emulator here, which just comes with Android Studio. It's just a QEMU emulator. And in the top thing, this thing you can see here, this is essentially just watching the folder directory for the screen captures we're about to get. Yeah, so this site, I'm just going to put in my primary factor here. You can email that domain if you want, or that email, it's not, I don't really monitor it. Spam away. So we've done the primary factor, and then on the back end, I've got Phantom.js running. That's just running somewhat headless Chrome with some actual rendering features, and it's just adding the first factor, and then it's taking the output of that first page, and then just waiting on that. And then we put in the second factor here. So I go to my free OTP, and I put in the second code. And what I did here is I put a really long timeout to kind of emulate some sort of server-side error that might happen. And then I redirected to the actual site here. So this is the real Heroku now. So what's mostly likely happening for the user now is they've had this phish email. They went to log into Heroku, my fake one. And then after that failed, I just redirected them to the real Heroku. Then they'll probably complain to support that there was some sort of issue with the logins. And as we can see now, if we look at the file system watcher, a dashboard should show up eventually once my thing finally screen caps it. And I'd saved you an app for all you guys called B-Sides Las Vegas 2017 on my dashboard in Heroku just to show you like that we did get the real Heroku here. Obviously, you could go to greater lengths with this. You could, for example, do full video stuff, or you could actually get like session cookies and then just browse to that as an attacker. But essentially, you have their session once you've completed this. And so that's one of the shortcomings of TOTP or HOTP. It doesn't defend us from attacks that target a specific platform. It would defend against, compromises of passwords, but not from a targeted attack like this. So when I was thinking of the issues here, I thought of the desired features of the solution that we'd want. So firstly, obviously, we wanted to protect from an attacker stealing the user's credentials, so the primary factors. And that would be via DNS hijack attacks, so whether that's some sort of DNS changer malware, some other router hacks, etc. We'd also want homoglyph hostname protection, which is not something, contrary to popular belief, that TLS would give us. TLS, you can have a secure channel to a bad place, right? It doesn't help with that. And then we also want to protect static inputs with variable inputs. And what I mean by that is if you think about the primary factor, you don't frequently change your password. With TOTP, that code is changing every 30 seconds. So we'd rather put in the thing that's changing first, because compromising that is not as catastrophic as compromising the static factor. And then also it'd be nice if it was technology agnostic. So someone could write a design, like maybe some UML, some sort of like RFC, and then it can be implemented in any language, your favorite language. I'd rather it wasn't a proprietary piece of hardware, and that was the comparison I'm making there. The other thing is, maybe in my perception of the people that I know, it seems that we've reached a point where two-factor is just a thing that people use, and users have kind of said, okay, we're okay with this level of friction. So I prefer not to add to that, but if we could make it seem like it's just about the same level of friction, but it's adding some more enhancements, that would be ideal. Less friction would be desirable, but if we can't do that, the same level of friction could be okay. So a proposed solution, weirdly enough, if we look at the original RFC from 2005, they even said, interestingly enough, you can actually use this in a bidirectional type way. And I only found this after thinking of a design to protect it. But essentially, the way that this works is the user would enter their token, the server would send back its token, and they both verify each other's HMAC-based one-time paths. And so there's two secrets in this exchange. This wasn't widely implemented by vendors, at least I haven't seen any vendors implement this. I don't necessarily think it's much more friction than what we already have. The only thing about HOTP is it's not great for multiple client supports because you have to keep counters in sync. So imagine you have like a counter one that's incremented here, and this other client doesn't know about it. This one's going to be out of sync with its HOTP generation. The good thing about time-based is that's a universal counter. And providing there's no attacks on network time protocol or something like that, that keeps all the clients in sync. So the one that I chose to use was TOTP, not HOTP. And I'll get to that in a second. So what I'm proposing is, say we take this example of this live.com, this Microsoft site, and then I've got this spoofed ive.com. So when the user first visits it, it sends a header, and the reason it's sending the header is just so that the browser extension that I've created can just listen for other headers that are coming through. Ideally, this would be baked into the browser, but you can't do that until you've proved that it's actually valuable. So then they would submit their username. I feel like giving away a piece of username is not a totally sensitive credential, so it's okay to release that. The server would then send back something called an X-fearless response. And the only variant that I've made here is I've concatenated to the flawed counter that we had this thing. I've concatenated an IP block. So this could be, for example, an IP range. It could be a static IP that you use for logging in. It could be an ASN number. Just something that is harder to attack than DNS. And so the attacker now would have to go after the box directly and compromise that box. And in that scenario, you need different protections. And so what this does is it stops a site in the middle from then utilizing this TOTP code and passing it down the chain, because the browser itself is going to do a DNS resolution against ive.com. So the browser itself would do a DNS resolution against ive.com. It would calculate the expected OTP code, and that would be wrong, because the actual code came from this one down here. And here I've got a demo of that. So what we have here is, in the top window, this is a site called fearless.pro. These are real sites now. I was allowed to buy these because no one cares about these. So this is fearless.pro. This is a real site. This is the one that we're going to try and legitimately log into. This is a homoglyph attack. This is various.pro/login. And then up there, we've just got the browser extension that I created. And that window at the bottom is just a debug window for any extra information you might want. So what we're going to do here is we're going to log in with this user1 password foobar. So first of all, we have to register with this site. And what's interesting about all of these schemes is the registration is the most dangerous part of all of this process. So it's the place where we need the most hardening, the most detection, everything. But that is indifferent across all these schemes. So once we register, it's going to give us a server secret and the time that the secret was created at. And we can just populate that in the browser extension. Obviously, if this was a production piece of code, it'd be more slick than this. It wouldn't just. This is more to illustrate what is actually going on to you guys to kind of show as a proof of concept. So now the extension is going to be listening for that particular type of OTP code to come across. So if we go to log in on the legitimate side, what we're going to see here is that I put in user1. I'm going to then receive a. If you see in the top corner, we've now got the TOTP code that came up as a notification. This is the client code. So the extension itself has already verified the server's TOTP code and checked that the DNS resolution for that was legit. So there's no site in the middle in this case. And then if we, where's play? If we continue, I'll show you how we do that against the site here. That's a homoglyph attack against this and how it resists that in this case. This is using a beta feature of Chrome called declarative web extensions, which I'll talk about in a sec. And we see here that it was actually blocked. We got a notification to say various.pro is blocked. This is not actually the legitimate site. And that's what we prefer. We prefer that there was some sort of smarts in our browser to protect us from losing our credentials in that way. This extension just will not give up the client code unless the server code has been verified. And that's it for that demo. So yeah, what just happened here? So who's a fan of UML? I'm expecting no hands. Like, yes, you guys are the best. Like, I really like plant UML. I think it's awesome, and you can also generate it in ASCII. Who doesn't love ASCII diagrams of like networks? Like, it's amazing, right? So anyway, this is the flow of what happened. So can you see my mouse pointer? You can, right? So anyway, the user requests the site, then they get this X-fearless in it, and what this does is it registers with these Google Chrome's declarative web extensions that it wants to listen for some sort of dynamic input from a header. And this is great because your Chrome extension can have like a secret cache, and it can generate dynamic headers that it wants to listen for. I don't know if Firefox has this. It might have this. I just haven't tried it yet. Then you input your username. Then you do a post request, and it will receive the TOTP code from the server. And what the extension then does is it uses the DNS resolution API to say, OK, where did that server TOTP come from? And it came from this IP. Then what it does is it checks, are these valid? So it computes, wherever it was. Great, where is it? It computes this thing. So this is what the client's going to compute based on the DNS resolution that it got, and it's going to compare that to what it received from the server. And then after that, it's just a normal flow. I mean, this kind of thing's arbitrary after this. You don't really need to use client TOTP. You don't need to use a password. You can use whatever you want. You could use whatever scheme after that. It's more this step that's the most important, bit, is this valid comparison here. And so the benefits of this scheme is credential phishing somewhat goes away because you're protecting the user from submitting this ephemeral code accidentally to a site that's using DNS hijacking. So the only way that the attacker could really go about attacking this, one is attacking the client directly via malware, breaking into the Chrome sandbox or something like that, or alternatively breaking into the actual legitimate server. Anything in the middle is somewhat protected by this scheme. The other thing that I want to kind of labor about is corrects the user trust model. I thought about drawing a graph for you guys, but I think it would be too confusing because I did not find it helpful looking at the graph. So essentially, if you think about when you sign up for LinkedIn or whatever site you want, when you first sign up, that asset has no value. There's no actual user details in there. It's just an empty portfolio, right? So that thing's of low value. But as it goes on over 10 years, it increases in value. So compromising a 10-year-old LinkedIn account is more valuable than compromising one at time zero. The way we currently have designed these schemes is users have to be the same level of vigilance all the way across. So from registration to 10 years down the line, they still have to be scrutinizing the site. And we know that their tolerance to changes becomes heightened as it goes on. So like if something changed, they don't care. They're just like, log in, I don't care. Like I've been to this site before. So what we want to do is we want to align our authentication schemes with that model. And what we've seen from the previous thing that I described is that it starts off, yes, at registration. That's the most risky point. But after that, this scheme is defending against that. And it means that as the value of the asset increases, the actual user scrutiny can decrease. They don't need to be worried about changes to the site. Challenges are that the client needs access to a DNS resolution API. When I say client, I'm talking about browser extensions, mobile device, etc. These things are coming from a user developer standpoint, but they're not available everywhere, and they're not available in the mainline. You've got to be in like a canary release, dev release, beta, etc. We have compromises between usability and secure isolation. So in this point, I put it inside the browser extension. But ideally, as I'll show you in a sec, I'd like to move this out to a mobile app, and the browser extension would just be more of a dumb client that's just referring on the DNS resolution that it got and the token it received from the server, and lets the mobile device do the verification of that. So we've just kind of got a few layers to it. User adoption, obviously this is not going to work in systems where users have not accepted using TOTP or push-based 2FA. So I don't know how to solve those problems because those people don't want to use these things yet. So yeah, future directions. There's an app called FreeOTP that Red Hat does. If anyone's from Red Hat, I've submitted some pull requests for like backfilling of tests. Is that you? I knew it was you. Anyway, so I've submitted some pull requests for test backfilling for that because I really like the app, and I like it that Google Authenticator is not a public, free, open source app anymore. They private sourced it after a certain point. So it's nice to be able to verify what this code is doing because this scheme is very simple, and like we should be able to verify this to the public. So I really like this one. Go check it out. The actual app called FreeOTP, which is maintained by Red Hat community. So I've started extending this, and what I'm looking to do here is we have this normal flow, this browser extension thing where it sends us the TOTP header, and then this dotted line here. This is using something called Firebase Cloud Messaging or Firebase something. It used to be called Google Cloud Messaging, and it allows you to set up a Google token-bound access channel called a device group, where your devices can speak between each other in kind of an authenticated manner in terms of they have a channel to speak to each other, essentially. And so in previous projects, I've done some work around that, so it seemed like an ideal fit to combine these two together. And all this would do is it would send it to an Android app, and then the Android app would do the verification, just as it is in FreeOTP. It would just look to the user as if they go into FreeOTP, they've logged into the site, and FreeOTP suddenly allows them to click on the thing, and then they can copy-paste it back into the browser and go with the normal flow. So as far as the user's concerned, even though this looks convoluted to us as developers or security people, they don't see any of this because this is all happening on the back channel via the cloud-based Firebase cloud messaging. And we can also do the similar thing with push-based. And what I'm calling this is a reverse push. So normally with push-based, we do this login, and then the server would send a push request, and then we'd have this approve or decline option. But instead, what I've done here is normal flow that we discussed earlier. We send it over Firebase, cloud messaging, and then all we do is we pop up an approved decline, and then if the user approves it, we do a reverse push. And this could be integrity checked with something like an app ID or some sort of signature that the server knows about. And then in this case, we've protected from an out-of-band approve or decline issue with push-based. Because obviously, if you tried to compromise this in a normal push-based scenario, some user could just get sent an approve or decline, and they might just hit approve. You might get lucky, right? In this scheme, there's no way for them to hit approve because approve decline won't become available until it's received this dotted line here. And that's it.
Any questions?
Can't help myself.
This guy.
This guy right here. All right, so this looks great. There's a lot that's very reminiscent here of the TGT acquisition in Kerberos, which has been around for 30 years. RFC 1510 defines the ASREC and ASREP process, which is very similar to the flow here. Might be worth looking at the lessons learned in the 4200 series around DNS resolution, around the use of pre-auth to prevent replay attacks, and see if that applies here, just to strengthen this protocol as you're defining it here.
That's excellent. Yeah, thank you.
In that same vein, it could even be valuable to consider using the existing Spanego mechanisms in the browsers and extending the HTTP negotiate header instead of creating something custom. So just something to think about. I could see where this could very well fit in there.
If I can exchange details with you afterwards, that'd be
absolutely,
great.
Yeah.
Hi, so I was curious how much you've looked into applying this to like some of the newer like 2FA schemes and stuff like that use certificate-based OTP as opposed to like TOTP.
I haven't looked into certificate-based. I've mostly just focused on counter-based OTPs and push-based, because those are the things that I encountered in user space more. I didn't have as much focus on enterprise-grade solutions because my angle of interest is consumers, like user level. And I would assume, I don't know enough about this, but I would assume that the certificate-based ones were more enterprise-related, and through that thing, I'd consider that security to be proprietary.
Yeah, maybe a lot of this can still apply.
Right.
I'm just curious.
Yeah, no, I should look into that. That's a great note. Thank you.
All right, I think that's everybody. Thank you so much. We'll see you in a bit.